So welcome to today's webinar. Again, we're doing the compacting 8th grade and geometry with statistics. And this is really for those of you that teach the compacted course, the 8th grade and geometry with statistics teachers. Welcome. I'm excited to share all this with you today. My name is Dawn Hood, and I am the middle level math education associate for the South Carolina Department of Education. My co-pilot is Janelle Mills, and she is our one of our secondary ed associates. By attending today's webinar, you will be eligible to receive 1 hour of credit renewal points. So make sure you fill out the form at the end to receive your certificate. Disclaimer on the use of artificial intelligence. The content presented is the intellectual property of the South Carolina Department of Education, SCDE. By participating in this event, attendees agree they will not record, capture, or share its contents without permission. Attendees agree they will not use artificial intelligence, AI, to capture or summarize the contents of the event. The SCDE reserves the right to remove attendees using these services. So please understand that we have worked hard to create these, and we want to make sure that we are the ones sharing them. Okay. All right, today's purpose. I want to demonstrate how to incorporate the 8th grade indicators in with the geometry with statistics indicators. So see how they mix together. And today's topics, first off, we're going to go right through the strands. We're going to start with data, probability, and statistical reasoning and how those indicators go together. And then we will look at how to incorporate some of the 8th grade indicators in with those and look at a few little activities. We'll move on to measurement, geometry, and spatial reasoning. Numerical reasoning is our third topic. And then fourth and final, we will talk about patterns, algebraic, and functional reasoning. We will be working in a couple of breakout rooms today using a participant slide deck for you to input your thoughts or create questions as you go. Janelle is going to put a link to that slide deck in the chat so that you can go ahead and pull that up and follow along. Get it, Janelle?
I'm moving a little slow, but I got
So while Janelle's getting that link into the chat, we'll go ahead and get started. We're going to start with data, probability, and statistical reasoning, like I said earlier. Okay. All right. You get it, Janelle? There we go. It's in the chat for you now. So starting with the DPSR, we have 8 DPSR 1-1, 1-2, 1-3, and 1-4. These 4 indicators are the ones that are our statistical pieces, create and analyze scatter plots to represent numerical data sets in mathematical and real world situations. And if you have your standards in front of you, it'll probably make it a little bit easier to get through today's webinar. DPSR 1-2 for 8th grade is draw inferences about 2 populations utilizing representative random samples of comparisons of the shape and distribution, measures of center, and measures of variability. 1.3, describe how adding and deleting data throughout the data set can affect the mean, median, mode, and distribution of the data. And for 2 data sets is 1.4, numerical, graphical, compare and interpret the centers, spreads, and overlap of data to draw inferences about data in mathematical and real world situations. And this one does limit your displays to double line graphs, back-to-back stem and leaf plots, and double box plots. So those 4 8th grade indicators and the 3 DPSR from geometry, how do they go together? So think about those 4, and I'm gonna read out the geometry ones in just a second. But like I said, this will be a lot easier if you have yours in front of you. If you don't, that's okay. But 1.1 for geometry is represent data for 2 quantitative variables on a scatter plot and describe how the variables are related. 1.2, use 2 representative points from the data to find an approximate line of fit and compare it to the line of best fit. 1.3 for geometry is conduct an investigation for a statistical question, interpret statistical significance in the context of a situation, and answer investigative questions appropriately. So when thinking about those indicators, do you have any ideas, any thoughts about how we could put them together? And get your ideas before I share what my thoughts are. So if you want to come off mute, you can, or you can type it in the chat box. I would like to hear from at least 3 people.
Can you repeat that question, Dawn?
I would like to know how you think some of these might go together, the 8th grade and the geometry. So I want your thoughts before I tell you my thoughts. And you can just tell me one combination if you think of something that would go together. So come off mute or put your answer in the chat. And I'll say at least 2 people this time. So GS DPSR 1.1 and 1.2 and 8 DPSR 1.1 seem to flow together well. Okay. Any other thoughts? I agree with that one. They definitely go together. What about the others?
Well, in geometry, it looks like you're taking it a step further to finding the line of best fit,
Yes.
and you're not doing that in 8th grade.
Right. So in 8th grade, we're just kind of looking at the how they fit together. Was it positive correlation, negative correlation, that kind of thing. But now we're going a little deeper and we're going to the line of best fit. Now for 8 DPSR 1.2, 1.3, 1.4, they don't quite fit anything here, a little bit with 1.3. And then we could probably sneak in DPSR 2.1 from geometry, which is, second, distinguish between correlation and causation. And that kind of goes with our 1, 2, 1, 3, 1, 4 from 8th grade. So these 5 can kind of loosely go together. And, you know, we're looking for how we can connect them with the students. So if there's a way to connect them, we want to do that because you don't want to have to teach extra. So really, we're looking at 1.4, 8 DPSR 1.4 to go with GS DPSR 2.1. Okay. So let's look at an example we could use. And this is where we're gonna find our first breakout room. So in a minute, we'll put you in breakout rooms to kind of talk over this question. Let's see, we've got 27 people. So I think we'll be all right with our 6 rooms, Janelle. So in the participant slide deck, when you get in your breakout room, make note of what room you're in, and that's the slide you're going to work on. It says like group 1 or breakout room 1, breakout room 2. So whatever room you're in is the slide in the slide deck you're going to use. I want you to think about how this question itself could be used to help teach some of those indicators we just looked at on the previous slide. And they're in the slide deck, so you don't have to keep going back and forth between, or you can go back and forth between the slides and look. I want you to record any questions you can ask to get students talking about this activity. And then how would you set this problem up for your students? So that's the focus of this one. So if this is a question or a problem it's actually from McGraw-Hill, what can we do to kind of get the kids included in this? So we're going to send you to breakout rooms if you don't have any questions before I send you there. Okay. So, all right, guys.
Yeah.
All right, guys. Bringing you back in. So I was looking at your slides as you were working on them. So tell me, what kind of questions you came up with that would help the kids move through this activity and meet the needs that we're looking for in that indicator. Got quite a lot in group 2, 3, and 4.
Well, for us, I was in room 4. DPSR 1.1 is create and analyze a scatter plot. So how do we turn this data into a scatter plot? So that's the basic part, is what's going to be our X value, what's going to be our Y value, how do we create the scatter plot from this? Once we have that, we start to draw inferences. So the question that was included, when does the wall need to be built? Or they want to have the wall built before the sea level reaches 4 inches. So one of the questions is, when would they need to have the wall built? And then going on to 1.3, are there any outliers? Is there anything that we could change? Any data that we could delete from this that would change that answer?
Good, good. Anything else y'all want to add? So would you want to dictate what intervals the students used on their X and Y?
This would be a good time for them to kind of try to figure that out on their own, to see what works, to see what doesn't work. I know in my class, we've been doing slope and learning slope in one of my 8th grade classes, and they've had to see that our y-axis is not always counted by ones. So they have to see it set up differently than it's 1-to-1 ratio. So this would be a good time for them to experiment to see, do I want to set this up by ones? Do I want to set this up by 0.5s or 0.2s? What works best for you? And then you have to give me your rationalization why you use that.
That's great. I love that. I would also maybe challenge the students if they can find another way to represent the data. I know that they would have the scatter plot, but is there another way to look at it and share the same information and see if they could come up with something? All right, what indicators did you think fit best? I know y'all said 811. What else? To me, it looks like you guys said all of those. GS, DPSR 1112, 81113. I saw some 14s. What process standards do you see embedded into this? We have the 5 process standards: problem solving, representation and communication, connections, analyze and justify, and then structure and patterns. Would
We'll
any of
definitely
those-
analyze and justify.
Okay. What makes you say analyze and justify?
You're having to analyze your data, and then like we were saying, when we set up our scatter plot, you have to justify why you set it up the way you did. So with that particular one, you would have to analyze your data in order to try to figure out what the question was. When is the water sea level going to be at 4? And then justify how you came up with that answer, how you set up your data, how you set up your scatter plot.
Mm-hmm. Okay. Any other process standards?
In the chat, we have problem solving.
Definitely problem solving, but you can tell me why. Multiple representations. Thank you, Leah. And then they have to understand this problem. They have to make sense of this problem. And that's the big piece in the problem solving. It makes sense. Any others y'all thought about?
I think anytime a student has to explain their ideas, we're looking at representation and communication.
Yes. So definitely, we've got 3 so far: problem solving, representation and communication, analyze and justify. Connections. I put down connections. I thought they could make connections here to things they had already done, which is a little bit of graphing. And of course, using slope. And I'm sure there's a way we can put structure and patterns in there. So this one, just a short little activity, we could probably hit at least 4, but maybe 5 of the process standards in the meantime while we're working through it. All right, thank y'all. So let's look at the next set of DPSRs. We've got 8 DPSR 2.1, which is our determine the sample space for a compound event. 8 DPSR 2.2, calculate and interpret the probability of a compound independent and dependent events. And then our GS DPSRs are 3.1, 3.2, 3.3. So that's describe categories of events as subsets of a sample space using unions, intersections, or complements of other events. 3.2, apply the addition rule to find the probability of both mutually exclusive and not mutually exclusive events and interpret the answers in context. 3.3, apply the multiplication rule to determine the probability of independent events and interpret the answers in context. Any thoughts on how these would go together? This one a little tougher? All right, so let's see. My thoughts are we could pair up DPSR 8 DPSR 2.1 with 3.1. Okay, and those again were 2.1 is sample space. So we need to know the sample space when we're looking at our categories of events. So DPSR 3.1 says describe categories of events as subsets of sample space. So they're going to go together a little bit, and then these three will work together to help students understand independent and dependent events. So this one, I believe this one's from Math Nation. I didn't put it up there, but I'm pretty sure this one's from Math Nation. Let me set this up for you. A survey asked 50 students about vacation preferences. The results are summarized in the Venn diagram. All right. So what do you notice and what do you wonder would be the first question you'd want to ask your students. Okay, but what do you notice and what do you wonder about these numbers? Any notices or wonders from the crowd? You can type in chat or you can come off mute. Amusement park is bigger than the camping ground. Thank you, Ben. How would you describe why is the 7 outside the circle? Are you looking at we're looking at my screen. It might be in the slide deck. I can't remember if this one's in the slide deck or not. For those of you not sure. Who was asked their preferences or what question was asked? How many is the total number of people asked about the event? It's not in the slide deck, then it's here on the screen. So second question, how would you describe? You don't see my screen? You might have to refresh. Sometimes when you come back from a breakout room, it messes up what you see. So, second question, how would you describe the intersection of the two events? What would you say the middle piece is?
Hey, it's Kathy.
Huh? No.
They like camping and amusement parks together. So those are the people who like both the camping and the amusement parks. All right. How do we write that? And what does it mean? I don't know if we have the right symbols that we could write that. These questions came directly from Math Nation's, I think it's the geometry with statistics piece. So these questions would be how you would set it up and ask the kids to try to understand unions, intersections, and complements. So in the intersection, we said that the 16 means that there are 16 students that would prefer a vacation at an amusement park. I can't talk now, and a vacation camping and a camping vacation. So together, that is our piece that's together. And then the union is 43 outcomes. That means there are 43 students who prefer an amusement park, camping, or both, the total number in the Venn diagram itself. So what does that 7 off to the side mean? inverted U. Thank you for sharing like that. A inverted UC is how we show, because yeah, we don't have those symbols. So 7 neither preferred the amusement park or the camping ground. So what that really is the last question, the complement. And so when we write a complement, we put the little tilde in front of it. So what is the complement for both or for all of them? It is the 7 off to its side. They chose not one of the other. If we just ask the question, what is the complement of camping? What would we figure it out? What would we come up with? So 19 plus 7. 19 plus 7. Be anything not in the camping circle. Good. So what indicators do you feel like this covers? It's really our goal. I was trying to speed up a little bit because I don't want to keep y'all beyond the time today due to my problems at the beginning. So what indicators again would you see this covering from the previous slide? Do I need to go back? We got GS, DPSR, 313233 or 8 DPSR 2122. What could we cover with this one? Sample space for 812. What about sample space in geometry? Does it cover that? Which was GS 31. Oh. DPSR 31 for geometry. Does that work? Okay. Anything else? Could we add any questions that would help us cover 3233 for GS or 8 DPSR 22? 8 DPSR 22 is calculate and interpret probability of compounded independent and dependent events. GS DPSR 32 is the addition rule and 33 was the multiplication rule. Could you add questions that would lead to those indicators? Could ask students to find specific probabilities. Okay. All right. Thank you, Francis. If I chose a student at random, what is the probability that they don't like camping? Love that question. I might have to write that one down. All right, y'all ready to move into MGSR? We're only in one. We got to get through a few more in about 15 minutes. All right. How about 8 MGSR 1, 2, 1, 3, and 1, 4? We look at some of the GS indicators. Let me tell you what 1, 2, 1, 3, and 1, 4 are, and that might help. So 8, 1, 2 is find the distance between any 2 points in the coordinate plane using the Pythagorean theorem. 1, 3, given the Pythagorean theorem, determine unknown side lengths in right triangles in mathematical and real world situations. 1, 4, determine if a given set of sides forms a right triangle. You know your geometry standards. Do you know any that would fit? And I'm not going to keep my wait time too long because we are running. We're going to run short of time if I don't move along. 1, 3 will lead to trig. Good. All right. Trig ratios. All right. So my thoughts were GS Poffer 3, the whole standard 3 will help with 1, 2 because it's all about gosh, it's all about Pythagorean theorem. And then GSMGSR 5.2 works with MGSR 1.3, MGSR 1.3, and then 6.1 fits pretty good with 1.4. So 5.2 is apply the attributes of triangles in mathematical and real world situations. And then 6.1, discover and apply the converse of the Pythagorean theorem, which is kind of what AMGSR's 1.4's indicator insight gives us. Distance formula for 1.2, good. All right. So here's a little activity that I thought could be used to help. This one kind of gives away the indicators, so I threw them up there on the screen. There's 6.1 and 8 MGSR 1.4 because it is exploring the converse of the Pythagorean theorem. So the setup for this problem is that students are supposed to trace all these segments on patty paper and then cut them out. And you know, my thoughts were that you have other options. You can do it that way, and then or you could use Anglegs or Exploragons. You can use straws cut to the different lengths, and then kids can manipulate them and see if they will create a right triangle. Maybe even some linking cubes. I think I'm gonna skip this breakout room, Janelle, because I don't know that we'll get through if we do another breakout room. But I gave you the Unit 5, Lesson 5. This is where it came from, was Math Nation again here. But some of my thoughts were that students could measure the segments and substitute it into the Pythagorean theorem, and then they can ask, what do you notice about the ones that make right triangles? What do you notice about the ones that don't make right triangles? So helping them discover that converse. They can always prove or disprove that the lengths form a right triangle using numbers. And then that will help them discover that converse, to know that the square of the longest side is equal to the sum of the squares of the others. Questions so far, y'all? Put them in the chat if you have a question. I'll try to answer as we go. And I hope this is making sense to you. All right, so the next set of MGSRs is just two of them, 8 MGSR 2.4 and 3.2. And my thoughts on these was that 5.1 could also go here with 5.2. So that's GS 5.1 and 5.2. So 5.1 is your justify and apply the attributes of angle relationships or lines in mathematical and real world situations. And then 5.2 again was apply the attributes of triangles in mathematical and real world situations. Then with 8.3.2, you can combine that one with quite a few. You got GSMGSR 2.1, 2.2, and 3.2. So 2.1, back up there to 2.1, is describe the results of transformations on a given figure using geometric terminology from the definitions of transformations. 2.2, describe and apply a sequence of transformations that maps a pre-image onto its image. 8 MGSR 3.2 was identify congruent angles and congruent line segments of a pre-image and its image. So I think those fit nicely together. And then GS MGSR 3.2 demonstrate that triangles and quadrilaterals are congruent by a combination of translation, rotations, and reflections. So moving to an activity that works well with that one. I hate that I've just pulled a bunch from Math Nation, but they had some ones that were easy to map. This one is one that we've actually seen in the geometry. If you were in the geometry with statistics PDs, the 2-day PD. So this is an exploration activity for students to begin to identify congruent parts of triangles. And what do they need to know before they start this activity? Can I hear from 2 people? How to do transformations. What else? Need one more. What congruence means. Good. So definites there. Okay. They may also need to know how to understand like the order in a triangle. If I'm saying triangle PQR, I need that P to match up with another angle that matches P. I need Q to match up exactly in the same order. Okay, corresponding angles and sides. All right. So what will this activity help them gain? Be able to identify congruent sides and angles, help with orientation. And orientation is the thing that messes them up the most. When a triangle's turned, they struggle with being able to match their corresponding angles and sides. It will help them tie congruence to transformations, understand more about congruence and transformations. Good. So my thoughts were to have students, what could students use to help them do this activity? Here's where your patty paper needs to come in. Using a sequence of transformations as an informal proof. Good. So patty paper comes in great here. Trace PQR. See if it fits. Where does it match? And then they can determine, okay, this is the way I would have to write my sequence. And then I would have them write an equality statement showing which angles are equal, which sides are congruent, or maybe an inequality. Okay. All right. Numerical reasoning, moving forward. I paired numerical reasoning with GSNR11 with our 2 Hoffer 3.1 and 3.2. So NR11 for geometry is rewrite numerical expressions of irrational and rational numbers involving radicals, including addition, subtraction, multiplication, and division to represent geometric patterns. And so can you guess what 8 Poffer 3.1 and 3.2 are? Those are our perfect squares and perfect cubes, and then our approximating non-perfects. Yes, Francis had it. So those will help build. If you start with the Poffer 3.1 and 3.2, then you definitely can work towards the radicals in the next one. So an activity that I do have a link to somewhere, I think it's linked in the slide deck, is where they can build perfect squares and perfect cubes. So you see just a piece of it here. So using square tiles, they can build the perfect squares and then give them cubes or linking cubes, and they can build their perfect cubes, and they can sketch what it looks like. They could talk about what it looks like and think about how to create these. I would deliberately not give them enough to make maybe 5 and 6 and ask them how they would be able to do that, and have them start thinking, okay, I have to pair up with another group and we'll have to make more. How many would they need to do? How many students, how many groups would have to get together to make hundreds? To make, I'm sorry, tens, not hundreds, but since this really covers just the 8th grade indicators, what can we add to it that would help with GSNR 11? Maybe asking some questions that would push their thinking a little bit to simplify a radical is where I was going with that. And I see we're close to time, so I'm going to try to get through the next couple of slides really quickly. All right, so what overlap do we see here? You'd have to know what's in those indicators to be able to answer that, but I will tell you what I know. 8 Poffer 22, 24, 25 is about slope. So they have to know slope before they get to those. And then they can determine the type of line that they see in GS22. I'm sorry, did not mean to do that. And then students need to use slope to determine the equation of a line in 8 Poffer 24 and 25, which goes with GS Poffer 23. Students will be analyzing two functions in 8 Poffer 15 to determine if lines are parallel, perpendicular, or neither, which goes along with GS Poffer 22. And then another little activity to help you work through it. How can students make sense of this problem? I'm going to give you the question that I would like, that would be a good one to answer. What would be the equation of the line for the sites he connects? And then I would always put in that extra, how do you know? That would be the equation that would fit. And this one did come from Savas. Yeah, I'm sorry that this took so long to get through. I didn't expect that.